All right, hey everyone, and welcome. Today, we're going to dive into one of C's most powerful and maybe a little intimidating features, function pointers. Seriously, if you've ever wanted to write code that's way more flexible, super dynamic, and just easier to manage, well, this is a concept you're going to want to master. So let's jump right in.
Okay, so let's start with a classic scenario. Imagine you're building a simple calculator. The user types in add or subtract or multiply. Now, how do you actually call the right function based on that input? I mean, sure, you could write this massive, ugly if-else chain or a big switch statement, but you just know there's got to be a cleaner, more elegant way to do it, right?
And that's the real heart of the problem, isn't it? We need a way for our program to choose which function to call while it's running. We need to stop thinking about functions as these fixed, static things and start treating them more like variables, something we can pass around and choose on the fly.
And that, my friends, brings us to the hero of our story, the function pointer. This is the classic, elegant C solution to this whole runtime problem. So what exactly is a function pointer? Well, you know how a regular pointer stores a memory address, right? Usually it's pointing to some piece of data, like an integer or a struct. But a function pointer is different. Instead of pointing to data, it points to the actual executable code of a function living somewhere in memory. Let's put that another way. Just think of it like this. It's a variable, but its value isn't a number or a string. Its value is a behavior. It's basically a placeholder that you can aim at any function you want, as long as that function has the right shape, which we'll get to.
Okay, so the theory is cool, but let's get practical. How do we actually write one of these things? Let's break down the syntax, the blueprint.
Okay, I know. This syntax looks a little wild at first glance, but I promise it makes perfect sense. You've got the return type, you have the name of your pointer, and then you have the parameter types. It's basically a contract, a template that says, I can only point to functions that look exactly like this.
Now look closely here because this is the single most important part of the syntax. See the difference? It's those parentheses around FPTR. They are absolutely crucial. Without them, the compiler would think you're declaring a function named FPTR that returns an integer pointer. But with them, you're telling the compiler, hey, FPTR itself is the pointer, a pointer to a whole function. Don't ever forget those parentheses.
So, how do you get it working? It's really just a two-step dance. First, you declare the pointer, making sure the signature is right. Then, you just assign a function to it. And here's a cool little quirk of C. You can use the ampersand, the address suboperator, or you can just use the function's name by itself. The compiler knows what you mean either way. Super clean.
All right, we've got the syntax out of the way. Now for the really fun stuff. Let's see these things in action and talk about the superpowers they give you.
And this quote really nails the first major superpower, the ability to pass a function as an argument to another function. Think about that for a second. This powerful technique has a name you've probably heard, a callback, and it is the perfect solution to that calculator problem we started with. No more messy if-else statements. So, check out the signature for our new calc function. It takes two integers, a and b, like you'd expect, but look at that third argument. It's a function pointer named op. This means our calc function has no idea what operation it's going to perform. It's totally generic. It just knows it's going to be giving some function to run.
And this is the beautiful payoff. We call the exact same calc function both times, but in the first call, we pass it the add function. In the second, we pass it subtract. We are literally changing the behavior of calc at runtime just by passing in a different function. Problem solved, and it's so much cleaner.
But callbacks are just the beginning. What if you have a whole menu of functions to choose from? Well, that brings us to the next superpower, arrays of function pointers.
That's right. You can create an array that doesn't hold numbers, but holds functions. Look at this. We've created an array called var that's basically a menu of all our calculator operations. In the real world, this pattern is often called a dispatch table. And once you have that array, calling a specific function is as easy as accessing an array element by its index. You want to multiply? Just use index 2. This makes your code unbelievably clean and so easy to expand. Need to add a new operation? Just add it to the array. That's it.
Okay, that was a lot, I know. So, before we wrap this up, let's do a quick recap of the most important rules to remember when you're using these. All right, quick rundown. Number 1, they point to code, not data.
Number 2, and this is non-negotiable, the signatures have to match exactly. Return type, parameters, all of it. 3, their whole magic is that you can change what they point to while your program is running. 4, and this is a big gotcha, you can't do pointer math on them. FPTR++ just doesn't work. It makes no sense. And finally, as we saw, they are absolutely perfect for building those super clean dispatch tables. So there you have it. We've seen how function pointers can transform your code, making it dynamic, clean, and just way more powerful. From simple callbacks to awesome dispatch tables, you've now got this tool in your belt that lets you treat behavior itself like a variable. So the real question I have for you is, what are you going to build with this? What clunky old if-else chain are you going to go refactor right now into something beautiful and elegant? Go give it a shot.